Hello, everyone. My name is Asenath Kiprono, and I work with Oxfam GB, managing the Global Solar and Water Initiative. For this first session of the webinar, we will look at solar pumping configurations and components and criteria for selection. So a typical solar pumping scheme looks like this. The layout is like any other pumping scheme, having a pumping device connected to a power source, which is a PV generator, through an electronic controller, and then pumping water to a tank for distribution for various uses. A more detailed schematic looks like this. The main components are a pump, again, to push water, a controller that allows the pump to run on DC power, and a PV generator made up of solar panels that produce the DC power. Storage here is also an important component, but that will be covered in another webinar. This graph here explains operation of a solar pumping system compared to a traditional pumping system. In a traditional system, you have a constant flow and water can be pumped for 24 hours, but is subject to factors of diesel availability, power outages, and so on. The basic principle of a solar pumping scheme is that the amount of water pumped follows the solar day, like you see on this red curve here. It varies throughout the day with the intensity of the sun, as shown on the graph, but and pumping is only limited to during sun hours. But even with this variable shorter pumping, a solar system is preferred, as evidence shows that it's sustainable, it's more reliable, and it's also cost-effective. It is also important to note here that solar pumping system design is done avoiding batteries, since we want to reduce cost and we also want to keep the system simple and efficient. Some background information on pumps. So a solar pumping system can either be DC or AC, and a DC system comprises of a pump that is coupled to a DC motor and then connected to the PV generator via a DC controller. On the other hand, an AC system consists of again of a pump coupled to an AC motor and connected to the PV generator via a DC-AC inverter. And pumps can also be either submersible or surface pumps. Submersible pumps basically are water cooled. They're installed completely submerged in water, and surface pumps are mounted on the surface as they are air cooled. Surface pumps typically are installed mounted on solid ground, but can also be installed floating on a surface water source, such as a river, a lake, or a dam, in order to overcome long suction distances, allow pumping even during low water seasons, and prevent the pump from flooding. And in this picture you see here, the pump is mounted in a pump house while the suction is floating in the river. Thus, the suction rises and falls with changing water levels. Sometimes also submersible pumps are installed floating in a surface water source in preference to a surface pump for the reasons of they have no complications with suction, they provide better efficiency, are simpler and less problematic to operate. And in this picture, the submersible pump is suspended horizontally and submerged floating in this dam. Solar pumping systems can also be installed in standalone or hybrid configuration. And when we talk of standalone, we are referring to a system that has solar as the only power source. And when a second power source is introduced, that becomes a hybrid system. I show you a few pictures to visualize the difference between solar standalone versus hybrid. In this first one, the solar DC power comes directly from the PV generator to DC isolation switches, and then to the controller, which can be a DC or an AC controller, and then feeds to the to a DC controller and then feeds to the pump. When a second power source is introduced, that's a hybrid system. And in this one, the DC power comes again directly from the PV generator to the inverter, And then an alternative power source comes from either a diesel generator or an AC power source through a changeover switch that changes over between AC and DC to power the pump. And this is a manually operated system whereby the switching is done manually. This one is also a manually operated system, the difference being that a single controller is used to power the pump from both power sources, from the DC power source and from the AC power source, but with a manual isolation between the two so that a single power source is present in the controller at any time. This one is also a hybrid system, and this is an automatic blending system that the private sector companies will also mention about. When it comes to selecting the right configuration, the selection of pump types and sizes is quite straightforward, especially due to computer-based software. We have found that the choice of whether to use solar standalone versus hybrid is the one that requires more insightful thinking, as the right selection will result in an optimized system that is more cost-effective. And choice for whether hybrid or solar standalone will be determined by the water demand, the solar resources available, and the water source itself, as well as other social and contextual consideration. And specifically in humanitarian and emergency interventions, where time is not always enough to get all the data needed for proper design, and where population sometimes can increase suddenly, it may be necessary to install a diesel system in order to provide a quick response as the solar pumping system design and procurement is being done. However, actual decisions should always be based on prevailing circumstances, as nowadays solar pumping design is also simple and fast and can be deployed quite quickly in the field. This is to say that solar should be seen as a viable solution right from the beginning, and a rationale made for installing diesel if necessary. Also, the need for quality data. Quality data collection is key, as the lack of good quality data is behind many installations, many poor installations and malfunctioning of systems. Yet when you collect the correct data, it can just take a few days and avoid such problems and make systems run well for many years. This graph shows a comparison between solar standalone and hybrid pumping. So if the demand is at 100%, then you have some supply coming from solar, and then any extra additional demand comes from the generator, usually during off-peak hours or at night time. When the demand, of course, is lower, maybe at 60%, then solar is able to satisfy the full demand. And the excess water pumped during the peak hours of solar can be stored in a tank and negate the need for a generator. And in many cases, we have seen in the field that when solar standalone is properly designed, taking into consideration the real conditions, it is able to meet the full demand. So it's all about rationalizing the design, and a second power source should only be introduced when it is clear that solar alone cannot meet the water needs together with other local considerations. We have come across many cases where diesel generator is rarely switched on, but provides a peace of mind in case solar does not work, which is really anchored on false fear and doubts towards solar. Economic analysis can also be used for decision making, prioritizing systems and targeting those with greater economic benefit, as you will see on this graph. Standalone will give you a greater cost saving than a hybrid system. And even though we know this, all other factors beyond the economic benefit should always be looked at, not just the economics. And in our various country visits, this table shows the sizes and configurations we have come across in the field from analyzing 140 systems in 8 countries. And to note here is that in all the 8 developing countries that we have visited, where there are humanitarian interventions, the private sector in all these countries have world-class components, good quality, even in unlikely countries like Somalia and South Sudan. They have the knowledge and expertise to install and support large systems too, and they can deploy these systems quite fast. and indeed they are already working with NGOs and UN for design and implementation. This really underscores the importance of building technical capacity within the humanitarian agencies to be able to provide oversight in system design and quality of materials, as well as supervision and control of installations, which will also enhance accountability on the part of the private sector. That is all. Thank you, and we look forward to hearing from you.